Greetings, Earthlings. Today we're going to look at program load. That's what this button does if you push it up. That's a switch, not a button. Whatever. I've implemented the microcode to do it, and so let me talk about that. It comes over the serial line. The data is in binary. It's not Intel hex format or anything like that. To try to decode ASCII characters in the microcode would just be asking too much. And besides, this is the way it's always been done. You know, if you think back to the olden days, if you were around in the olden days, if you've ever been to the computer museum, whatever, you had your old ASR 33 teletype with the paper tape reader, and the paper tape had a binary image on it, and you would load that into your computer off of the paper tape. So because we're sort of modeling it on paper tape, what I've done is I've defined a start character, and it will ignore everything before that start character when reading the program in. This is equivalent to the leader on the tape. The leader was typically all zeros, but sometimes they would punch they'd use the tape as a 5x7 dot matrix and punch a code number in there or some text or something. In this case, you couldn't hook an ASR 33 to this machine because it won't run that slow. 110 baud, I don't have that data rate programmed in, and so it's going to come most likely from an active device such as a laptop or some other interesting device to be defined. So there's a control code. It's FF, a value of FF. It'll ignore everything up until that. And then there's a series of 2-byte records. Because address and data are 12 bits on this machine, that leaves 4 bits in those 2 bytes, which I can use as control codes. So there are 3 control codes defined. A control code of 0 means store the remaining 12 bits of this 16-bit value into the current memory location. A value of A in the control code says set the remaining 12 bits of this 16-bit value into the address. And an address of E says end, and the remaining 12 bits specify the starting address of the program so that it will set the program counter to that value, and you can actually start the program by pressing continue rather than setting the address in the switches. So switches are wonderful things, but if you have bigger programs, then you want to be able to load the thing in a more convenient manner. So by way of example here, I've reworked the Hello World program. And I say reworked it because I did change some instructions, and I was able to eliminate an instruction in this code because I can now move the incremented value of the indirect register to the accumulator rather than moving just moving the indirect register to the accumulator and then incrementing the accumulator. I can do those 2 instructions in one. So this is the new code. Some of the opcodes have changed as well as a result of that change. And we've seen before, I toggled that in, but I've hand assembled the code and created a binary file over here on my laptop, which has the code in it that we just saw. And you'll see also that there are some leading zeros here to indicate the tape leader, if you will. You could put the program name in there if you wanted or whatever. There's the code. And so to load it in the machine, first of all, we have to turn on the machine. And it goes blink. Okay. And then we press load. Now it's waiting, and you'll see this sort of rather distinctive pattern in the lights that indicates that it's waiting for that start character. So over here on the laptop, what I'm going to do is, let's see. First, let me make sure that the port is set up correctly. I've got it currently at 2400 baud, so, and it's on COM5. So I'm going to set that. I said I'm going to set that. Press Enter instead of Shift. Okay, we're set to 2400 8N1 or N81. And now I can just copy that file to the computer, helloworld.bin to COM5, and then you watch the blinky lights on the computer here. Well, I got to do this without. Okay. You go blink, 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 and it's done. That's an odd starting PC value. I don't think that's right. It could be a bug. E000. That should be all zeros right there in PC. Okay, so there's a problem there. Let's have a look here. Now, you know, when I turned it on, it initialized all the memory to 0. Oh, and it's still all 0. That's a problem. That's a problem. What happened? All right, I think it loaded okay this time. I don't know. I don't know what happened the last time. Let's examine. Okay, 220 F00 F03 FFC FFF FE2 F11 106. And then the next address to have anything will be 20. That's 10. '20 has 30 in it. And then we go to 30. And we'll see the text, okay? So now to run this, I will bring up Hyperterm over here. Hyperterminal. Using COM5 and make sure the data rate at 2400 8N1. Okay. Hit enter and we can see it's connected. So going back over here, I press start. I'm going to have to do a split screen. Okay, but I press start and you say hello world. And I can run it again and again and again and again. So that's it. Obviously not quite perfect yet because I don't know, again, I don't know why it didn't load properly the first time. It's been working every time I tried it before I did the demo. Isn't that the way demos always work though?